Have you ever just looked around the room and wondered, what is all this stuff actually made of? Your desk, that coffee in your mug, even the air you're breathing right now? Well, today we're going to pull back the curtain on the secrets of stuff, and it all kicks off with one simple question. So let's start with a little riddle. Just think about it for a second. You've got a solid pencil in your hand, the invisible air all around us, and a giant blazing star millions of miles away. What on earth could possibly connect those three things? And the answer? It's actually super simple. They are all matter. Yep, that's the one word that connects pretty much everything. It's all the stuff you can touch, see, or even feel. It's the basic ingredient of our entire universe. Okay, so to really get a grip on the world, we have to start with the basics, right? In this first part, we're going to break down what this stuff, or matter, really is, and how we even begin to describe it. So here's the official definition for you. Matter is anything that takes up space. We call that volume and has mass, which is just a fancy way of saying how much stuff is packed into it. A book? Well, that's easy. It's got mass and volume. But get this, so does the air in a balloon. It's super light, yeah, but it's definitely there, taking up space. To really talk about matter, we use its properties. So mass tells us how much material we're dealing with. Like a big bag of sugar has way more mass than a single feather. Volume is just how much room it takes up. Simple as that. But the really cool one is density. It's how those first two relate, how much mass you can cram into a certain amount of space. And that's exactly why a small, dense metal coin sinks like a rock in water. And here is a perfect, everyday example of density in action. You've seen this in your salad dressing a million times, right? The oil always floats on top of the vinegar or water. That's just because the oil is less dense. Its stuff just isn't packed together as tightly. And understanding that simple idea is huge, whether you're in the kitchen or trying to clean up a massive oil spill. Okay, so we know what matter is, but it doesn't just show up in one form. Next up, we're going to explore the three main faces or states of matter that you and I run into every single day: solid, liquid, and gas. First up, solids. I want you to picture the particles in a solid like a perfectly organized audience in a movie theater. Everybody's packed in tightly, right next to each other in their fixed seats. Now, they might be vibrating a little, buzzing with excitement for the movie, but they are not getting up and wandering around. And that's why a solid, like an ice cube, keeps its shape. Now, liquids. If solids are an audience stuck in their seats, then liquids are like the crowd at a party. The particles are still pretty close, but they can move around, sliding past each other, maybe to go chat with someone new. This freedom of movement is why water has a set volume, but it'll take the shape of any cup you pour it into. And last but not least, we have gases. The particles in a gas are, well, they're like toddlers who just had way too much sugar. They are full of energy, bouncing off the walls, and spreading out to fill every single inch of space they can find. That's why if you spray a little perfume in one corner of a room, you can eventually smell it everywhere. Those gas particles have expanded to fill the whole place. So we have solids, liquids, and gases. But here's the really cool part: matter can actually switch between these forms. It's not locked in forever. And this amazing transformation is called a phase change. And believe me, it happens all around us all the time. And here is the single most important thing to remember about this. When matter changes its state, its basic identity doesn't change one bit. This is so crucial. An ice cube that melts, it's still water. It's made of the exact same H2O molecules. They're just arranged a little differently now. The journey of water is the perfect way to see this. You start with solid ice. You add a little heat, and it melts into liquid water. Add some more heat, it boils and turns into a gas we call steam. Then, if that steam hits a cool surface, like your bathroom mirror after a hot shower, it condenses right back into little droplets of liquid water. See? Same stuff, just different phases. All right, let's add one more layer to this. Most of the stuff we interact with isn't just one single thing. It's a combination of things, which leads us to a really important question. What's actually in your morning cup of tea? The difference is actually pretty simple. A pure substance is made of only one type of particle. Think about pure distilled water. It's nothing but H2O molecules. On the other hand, a mixture is when you have different substances that are just physically combined. So your tea is a classic mixture of water, all those compounds from the tea leaves, and sugar molecules, all just stirred together but not chemically connected. So far, we've talked about physical changes, like melting ice or mixing sugar and tea. But now we get to the really dramatic stuff, the chemical change. This is where stuff gets a total makeover and becomes something completely new.
This right here is the big distinction. On the left, a physical change. You melt ice, you still have water, you can pop it back in the freezer and reverse it no problem. But on the right, that's a chemical change. When you burn a log, you don't have wood anymore. You have totally new things, ash and smoke. And let's be honest, you can't exactly unburn the ash to get your log back.
That's the million-dollar question, isn't it? Since you can't actually see the tiny little molecules rearranging themselves, what are the clues you should look for? How do you know when you've just seen a true chemical makeover? Well, chemists are like detectives, and they look for telltale signs. A big color change, like shiny iron turning into that reddish-brown rust, the fizzing of gas bubbles being created, a brand new smell, could be good, could be bad, or even a sudden change in temperature, getting hot or cold all on its own. These are all clues that a completely new substance has been born. And here's a delicious example for you. Baking a cake. Think about it. You mix flour, sugar, eggs, and butter. But after that thing comes out of the oven, you don't have those separate ingredients anymore, do you? You have cake. The heat from the oven caused a whole series of chemical reactions that transformed that gooey batter into something totally new, fluffy and delicious. Okay, we've gone from the very basics of matter all the way to chemical reactions. So now let's zoom back out and ask the most important question of all. Why does any of this actually matter in our day-to-day lives? The answer is pretty simple. It's everywhere. These fundamental rules aren't just for a science lab. They govern the world all around us, from the food we cook in our kitchen to the medicine that keeps us healthy. Just think about it for a second. Cooking is basically a masterclass in phase changes and chemical reactions. Creating life-saving drugs depends completely on understanding how these substances combine. Keeping our water clean is all about separating out mixtures, and building new technology, from our phone screens to stronger materials, is all chemistry in action. So, I'll leave you with this final thought. Just take a second and look around you right now. The plastic of your mouse, the paint on your walls, even the process of your body digesting its last meal. Now that you know the basics, can you see the world just a little bit differently? Can you spot all the chemistry happening right in front of you? Thanks for diving into this with me.